This is section 15.2, and we're going to cover the concept of U-substitution. So what we've encountered so far when we've been taking derivatives were really easy, and we had rules that worked. And so we may encounter things where we don't seem to have a process, a concept to do that. And there's three main places that we see this, and we're just touching on this. Number one, when you have a quantity under a radical or raised to a power. Sometimes the exponent on e, and sometimes a quantity in the denominator. Those are three cases where sometimes we see it and it's not going to work out right unless we do what's called a U-substitution. So let's look at this, and I've color-coded this one. So we have the integral of 2x minus 3 over x squared minus 3x dx. Well, that's a quotient. We don't have a quotient rule or anything else. But what we kind of look for, remember quantity in the denominator. So if we look at the denominator, it's x squared minus 3x. So if I let u be that, then I take the derivative of this thing. The derivative of that is 2x minus 3 dx. Well, that covers everything we have up here. Here's my derivative I took. Here's the u that I let. And so we'll rewrite the question using our substitution. We have the integral of 1 over u du. And so my du is this up here in the green. So 1 over u, and we have our du. Then we're able to take the derivative, the integral of that. The integral of 1 over u is ln u plus c. You back substitute whatever you let u be. That was x squared minus 3x. So we have ln absolute value of x squared minus 3x plus c. That's going to be our process. And I've tried to color code where I could. The more you do, the more you'll begin to look for certain things. Let's go look at the problems. All right, so number one has the integral of 5 parentheses 5x minus 10 to the fourth dx. So remember we said something to a power. So if I let u be the 5x minus 10, and I take the derivative of that, so du would be 5 dx. Well, I do have the 5 and I do have the dx, so I've covered everything. So I rewrite this problem as the integral of u to the fourth du. So I've covered everything. Then I take the integral. That becomes u to the fifth over 5 plus c. I substitute back in, so I put my 5x minus 10 there. So I've got 5x minus 10 to the fifth over 5 plus c, or you could rewrite that as 1/5 of that plus c. Either way should work. All right, let's look at number 2. We have the integral of 8 over 8x plus 9 squared dx. So u is 8x plus 9. Take the derivative of this. That's 8 dx. We've covered everything that's up here. So rewrite as 1 over u squared du, or we could make it u to the negative 2 du. That'll be easier for us. So when we integrate this, we have u to the negative 1 over negative 1 plus c. Substitute back in. We'll put our 8x plus 9 back in, so we have negative 8x plus 9 to the negative 1 plus c. Since we don't really like the negative exponents, we'll put that on the bottom. So we have negative 1 over 8x plus 9 plus c. All right, now number 3, we encounter something a little bit different. We have the integral of 48 t to the 7th e to the negative t to the 8th dt. So the first thing I would do is to pull this 48 through. So when I rewrite that, I've got that. All right, remember we talked about letting u be the exponent on e when it's something like this. So if u is negative t to the 8th, and you take the derivative of that, you get negative 8 t to the 7th dt. Well, we have a t to the 7th and we have a dt. We do not have the negative 8. So I need to bring that to the other side. I need to divide that out. So if I divide by negative 8, I have negative 1/8 du equals t to the 7th dt. So now I've covered everything. So when I rewrite the problem, outside of the integral, I have a 48 and I have a negative 1/8. The integral of e to the u du. E to the u du. And then I'm going to integrate that. First of all, 48 times negative 1/8, that's negative 6. The integral of e to the u is e to the u plus c. And so I have negative 6 e to the negative t to the 8th plus c. Or you could put this on the bottom and make it a positive exponent. So negative 6 over e to the t to the 8th plus c. That would be number 3. All right, number 4, we have x cubed plus 3x over this dx. So we typically want to look at the denominator, let u be that. Du is going to be 4x cubed plus 12x. The 7 goes away and we have a dx. So we do not have a 4x cubed plus 12x. But if we divide by 4 here, if I take 1/4, divide the 4 over here, I'm left with x cubed plus 3x dx. That's the blue part up here. So when I rewrite my question, I have the 1/4 on the outside, integral of 1 du, that's up there, over u. The integral of that is 1/4 ln absolute value of u plus c. Plug your u back in, which was this in yellow. So I have 1/4 ln absolute value of my original u plus c. That would be number 4. Number 5 is a little different as well. We have the integral of p times p plus 7 to the 7th dp. So in this one of the things I would suggest we do, if u is p plus 7, then we still have this p here that we're not going to get by just taking the derivative. The derivative of this thing is the dp. But if we solve this for p to find out what we could substitute here, p is equal to u minus 7. All right, so keep that in mind. U is p plus 7, du is dp. So I'm going to rewrite this as u minus 7, that's the p, times u, which is p plus 7, to the 7th du. I'm going to go ahead and multiply this, distribute this. So I get u to the 8th minus 7u to the 7th du. It's kind of a roundabout way, but it does work. So now when I integrate, I get u to the 9th over 9 minus 7u to the 8th over 8 plus c. We're going to plug back in with our u, and we have p plus 7 to the 9th over 9, and minus 7, p plus 7 to the 8th over 8 plus c. And that's our final answer for number 5. Number 6, we have a radical. The integral of the square root of t to the 9th plus 5t, and on the outside of it we have 9t to the 8th plus 5 dt. So if we let what's in here be our u, t to the 9th plus 5t, if we take the derivative, we get 9t8 to the 8th plus 5 dt. So in this one, we were good. So remember that the square root of u is equal to u to the 1/2. That'll make it easier to do our integral. So we have rewrite here. Integral of u to the 1/2, because of this, du. When we integrate, we add 1, so that becomes u to the 3/2, and it's over 3/2. When we want to make this 3/2 come up here and be on the same line, you're dividing by 3/2, it's like multiplying by 2/3. So we have 2/3, we substitute our u back in to the 3/2 plus c. And that's, That one really went pretty nicely. It was pretty straightforward. Number 7, we have the integral of 19 over x ln 7x dx. All right, so think about this. If u is ln 7x, the derivative of that is 1 over x dx. Well, we have 1 over x dx, so that works pretty nicely. We pulled the 19 through, and so that was the first step. So when we rewrite the question, we have 19 times the integral of 1 over u du. That makes it 19 times the natural log absolute value of u plus c. The u, remember, was ln of 7x, so we have 19 ln, and in our absolute value we have ln 7x plus c, because we had to substitute that back in. That is our number 7. Our last one, number 8, is integral of this quotient. So if I let u be 4x squared plus 12x, if I take the derivative of that, I get 8x plus 12 dx. I don't have that up there, but if I divide by 4 on both sides, I do get 2x plus 3 dx, and I have 1/4 du. Rewrite as 1/4 the integral of 1 over u to the 5th du. And so that's the same as if we make that u to the negative 5 du. All right, when we integrate, we get u to the negative 4 over negative 4 plus c, and I had my 1/4 out here. So when I multiply across the top and bottom, I have negative 1 u to the negative 4 over 16. I took the negative here and just put it out front, plus c. Then I'm going to substitute back in, and here was my u, so the 4x squared plus 12x goes in there, to the negative 4, I have a negative 1/16. If we push this to the bottom, we have negative 1 on the top, the 16's already on the bottom, this to the positive 4 is now on the bottom, plus c. So those are 8 questions using U-substitution that should go fairly easily now that we've talked about the strategies.